Okay, today we're going to be talking about stoichiometry, and hopefully this will help you if you're still struggling to work some of the problems. We're going to work through a couple of problems, and if you'd like, when you first see the problem, you can stop the video, try to work it on your own, and then start it back to see if you got the answer correct. Hopefully this will be helpful. We're going to start with a fairly simple problem. All right, what mass of oxygen is needed to burn 350 grams of propane? All right, with all these problems, the first thing you need to do, you need to start with a balanced equation. And so the first thing you need to do is write an equation and balance it. This, if you haven't been able to recognize it yet, is basically a straight up combustion. So we're going to start setting up the equation. Spread it out a little bit so it's easier for us to have plenty of room to work. And like all combustions, the products, well, all combustions of hydrocarbons, the products are going to be carbon dioxide and water. So after we've got our equation set up, we need to balance it. So okay, that should be it. 3 carbons, 8 hydrogens, 10 oxygens on each side. Yep, that's it. So now that we've balanced our equation, we can go ahead and get started with the actual problem. Let's look and see what the question is actually giving us and what it's asking. First of all, it's giving us, we have 350 grams of propane, and it is asking us for the mass of oxygen. So we can put our givens right here. And then, of course, what we're trying to find. You don't have to do it this way, but I like to actually divide up my equation into sections and kind of write my answers underneath to kind of keep them organized. You don't have to do this, but I find that it helps me not get lost in the problem and keep track of my information. So now that we have our given, first thing we need to do is we need to recognize that the coefficients are molar ratios of reactants and products, which means you can't use masses when you're trying to work with these molar ratios. So you have to convert everything to moles first. So I was given grams, so that's not going to work. So I need to convert it to moles. And to do that, I need the molar mass. Starting with propane, it's going to be 12.01 times 3 plus 1.008 times 8 hydrogens. And the total for that's going to be 44.1 grams per mole. I like to keep my units with everything so I can not forget what the numbers mean. For oxygen is 16, but it's O2, so it would be 32.0 grams per mole. Put a little arrow there so you can see where the number came from. All right, now we can convert our grams to moles, and it's just a straight conversion like you've probably done several times. 350 grams times, put your grams on bottom so your units cancel. Okay, and that gives me 7.94 moles of propane. I'll go ahead and put that there below my propane column. Okay, now that I have moles, I can use my coefficients, my molar ratios, to determine how much oxygen I need to go with that 7.94 moles of propane. So you can do that. You can just multiply your number of moles by 5 oxygens over 1 propane, and then you can use your calculator. The answer there is 39.7 moles. I put that there in my oxygen. Oops. oxygen column. Now, the question asked us for mass of oxygen, and we have moles, so now you'd have to simply convert this back to, since this is moles of oxygen, you just convert it back to grams using your molar mass of oxygen. Okay, and punch that into the calculator, and your final answer should be 1,270 grams. So let's erase that. 1,270 grams of oxygen. 3 sig figs, just like your starting data was, 3 sig figs. Okay. Now, this one was fairly straightforward. We want to look at a limiting reactant problem. It's a little bit more complex, so let's take a look at it. All right, based on the equation below, if 23 grams of hydrochloric acid reacts with 18 grams of magnesium, what would be the mass of hydrogen produced? Okay, in this case, you're given 23. Oh, gotta switch my layers here. You're given 23 grams of hydrochloric acid and 18 grams of magnesium, and then you're wanting the mass of hydrogen. So, first thing we need to do, we have an equation. We need to make sure that it's balanced, and I'm going to actually spread it out just a little bit so we have a little bit more room to work, so it's not so crammed. Okay, and looking here, it looks like we need to put a 2 there, and yeah, that has us balanced. So once again, I'm going to draw some columns here to kind of keep things organized. You don't have to do this, like I said, it just helps keep things straight and keeps things kind of neat and organized looking. All right, we got a balanced equation, so let's put our givens. We have 23 grams of, 23 grams of HCl, 18 grams of magnesium. Okay, once again, we have to convert these to moles in order to be able to work within our molar ratios. So let's look at the periodic table. All right, so here's magnesium. Here's magnesium, so 24.3 grams per mole. All right, let's go back up to our 24. All right, HCl, we can calculate that. Hydrogen's 1.008. Chlorine is 35.45. And the 3 sig figs, that gives us 36.5 grams per mole. All right, now we can do our conversions of 18 grams of magnesium. Once again, you want to put your grams on the bottom so your units cancel. All right, and that's 0.741 moles. Okay, here, 23 grams of HCl. In this case, all right, now we have to decide which one is going to be your limiting reactant. The easiest way to do that is to take the moles of each reactant and divide it by the coefficient. In the case of magnesium, If you divide it by the coefficient, it is obviously the same. It's a coefficient of 1, so it's 0.741. If you divide the moles of hydrochloric acid by the coefficient, it would be 0.315. Okay, now that you have these two numbers, the lower number will be your limiting reactant. So in this case, this is your limiting reactant. So I'm going to go ahead and circle my moles of limiting reactant so I remember which one it is. Now that I'm done with that, I'm going to scratch out these numbers. You don't need to use them. They will confuse you if you try to use those numbers in your calculations going forward. So now that I know my limiting reactant, I can use my moles of limiting reactant to calculate how much products I use, how much reactants I produce. I mean, I said that backwards. How many reactants, or how much reactants I use, and how much product I produce. All comes from the limiting reactant number. So, the question was mass of hydrogen. So we take our moles of our limiting reactant. All right, and this is, let's write HCl there for clarity. Okay, so I have 1 hydrogen for every 2 HCl, and so that equals 0.315 moles of hydrogen. Okay, the problem wanted it in grams, so basically if I just take, running out of room here, 0.315 moles that's going to give me a final answer of 0.636 grams of hydrogen, and that is your answer. All right, let's take this one step further, and we can also use this limiting reactant to determine how much of the magnesium we'll have left over. The magnesium is what we refer to as an excess reactant, meaning you have more of it than you need. I will use some of it, but I will not use all of it. So how do you determine how much you will use? Well, that's pretty simple. You just use the limiting reactant and calculate it just like you would any other reactant or product. So we can take, find a spot to work here, 0.630 moles of HCl times 1 magnesium per 2. And once again, it's 0.315 moles. Now, this is the amount of magnesium that you use. So, if you want to know how much magnesium you have left over, you subtract what you use from what you had to start with. And my answer is 0.426 moles. Okay. In summary, let's go back through the steps that we did to solve these problems. First of all, we want to start with a balanced equation. Second of all, if you're not given moles, you need to convert everything to moles. Do not work with grams or any other mass. You have to convert it to moles. So convert to moles if you need to. Then number 3, if you need to, find the limiting reactant by dividing the moles of the reactant by the coefficient. Then you take the reactant with the lowest number. It's the limiting reactant, and you use it to calculate the products and the amounts of the reactants used. Then, of course, the last step is if the question wants mass, you have to convert your moles of product to grams.